So here we have another partial fractions problem where one of the terms in our denominator has a power of 2. So as you can see, the denominator is already factored out. You can't factor it more than it is right here. So let's remind ourselves how to do partial fractions with this. So we're just going to look at the integrand right now. So we have 1 over x minus 1 times x plus 2 squared. So this x minus 1 term we can take care of the same way we did in the last video, which is just put a constant on top and it on the bottom. And then now we got to take care of this x plus 2 squared term, and what we're going to do is we're going to still put constants on top, and we're going to build up the powers of this x plus 2 up until we get x plus 2 squared. So the first term is going to be b over x plus 2 just to the first, and then we're going to build that power up until we get the power that we have, which is x plus 2 squared. So we only needed 2 more terms. Let's say this x plus 2 was to the third. We'd have, this would stay the same, we'd still have these two, and we'd have another d over x plus 2 cubed. But in this case we just have it squared, so we just have these three terms. So once again, let's multiply out by this denominator, and on the left side we get 1, and then on the right side we get an a over x minus 1 times that whole denominator right there. And then we have the b term, which is b over x plus 2 times that denominator. And we'll do the same thing with c. Okay. So now that we wrote that out, we can notice that a lot of stuff cancels out once again. Pretty much that's always going to happen in these types of problems. So the a, the x minus 1's cancel out. For the b, one of these x plus 2's canceled out. And for the c, both of them cancel out. So we have squared both on top and bottom. And let's rewrite that. So we have 1 times a, and let's see what's left is just an x plus 2 squared, plus b times, well, we're left with x minus 1 and one of these x plus 2's, and then the c is left with just an x minus 1. And from here you can do what we did in the previous video, which is just pick values for x, and your first value would be -2, and you'd be getting rid of the a and b, and you could solve for c that way. And then you could pick x equals 1 and get rid of the c and b and figure out a, and then pick x equals 0, and since you already know what a and c are, you can figure out b. But I'm going to go over another method, which you guys are sometimes going to have to use when sometimes you aren't going to be able to find values for x that'll cancel things out in a way that'll help you. So let's go over this other method, which is just to look at the coefficients of all the x terms. So what that means is first we're going to expand everything. So we get a 1 equals ax squared, and then that's going to give us an a times 4x, and then plus another 4a. So all I'm doing is I'm multiplying this out. So that'll give me x squared plus 4x plus 4, and I'm multiplying that by a. So I'm going to do that same thing with b, and that gives me, let's see, that's a bx squared plus 2bx minus bx, so that's plus bx. And then the constant is just going to be what we have, -2b. And for the c, that's pretty easy. That's just cx minus c. So all I did is I multiplied that out, And I skipped a couple steps to simplify just to make this video shorter. And well, now look at this left term. Since the right side is going to equal the left side. The left side doesn't have any x squareds or x's in it. So what that means is that the coefficients of the x squareds and the x's, when you add those up, those are going to have to equal zeros. And when you add up the coefficients of all the constants, all the values that don't have x, that's going to have to equal 1. So let's first look at the highest power that we have, which is the x squared. So what are the terms that have an x squared in them? Well, we have just this a and b. And we have a positive a and a positive b. So what that means is that a plus b is going to have to equal the x squareds on the left side, which is just 0. And if we do that with the x's, we have a 4a here. And then we have a b right here and a c right here. So 4a plus b plus c is going to have to equal the x's on the left side, which once again is 0. And now let's look at our constants. Well, we have a 4a, negative 2b, and then a negative c. So 4a minus 2b minus c is equal to the constants on the left side, which is just this one right here. So now we have 3 equations and 3 unknowns, and you guys know how to do that. I'm just going to go ahead and tell you what a, b, and c are, and we get a is 1/9, b is negative 1/9, and c is negative 1/3. So that's just another method of determining a, b, and c. And if you did it the first method, you should still get these numbers. So you guys can practice doing that too, and you should get a equals 1/9, b equals negative 1/9, and c equals negative 1/3. So let's go back to our original problem, and that's the integral of 1 over x minus 1 over times x plus 2 squared. So now we're going to rewrite this line using our a, b, and c values, and go ahead and do that in another piece of paper. What we had was 1 over x minus 1 times x plus 2 squared was equal to a x minus 1 plus b times x plus 2, and then c times this x plus 2 squared. And once we found out that a is equal to 1/9, b is equal to negative 1/9, and c is equal to negative 1/3. Let's go ahead and plug that in, and we get that 1 over x minus 1 is x plus 2 squared is equal to a is 1/9, so 1/9 times 1 over x minus 1, and then b is negative 1/9, so minus 1/9 times 1 over x plus 2, and then c is negative 1/3, so negative 1/3 times 1 over x plus 2 squared. And if this was an algebra class, you'd be done, but remember, the original question was the integral of this. So to find the integral, we take to find the integral of this with respect to x, we have to take the integral of this side with respect to x. And all we have to do for that is take the integral of these 3 pieces. So let's look at this first piece. Well, we have a 1/9 out here, and the integral of 1 over x minus 1 is just the natural log of x minus 1. Now let's look at the second term. We have this negative 1/9 that we can pull out, and the integral of 1 over x plus 2 is just the natural log of x plus 2. And now we have this negative 1/3 1 over x plus 2 squared. Let's do this down here. So I'm going to rewrite that as negative 1/3 times x plus 2 to the negative 2. Because remember, if we're dividing by the squared, it's the same as multiplying this to the negative 2. And we can just use a power rule and get that that's going to be equal, well, the negatives cancel out once we do it. So 1/3 times x plus 2 to the negative 1 times the derivative of x, which is just 1, so I'm going to leave that alone. And let's just rewrite that as 1/3 times x plus 2 to the negative 1. That's just 1 over x plus 2. So let's put that up here. And we got 1/3 times 1 over x plus 2. And once again, we can use our log rules and factor out this 1/9 from both of these. And log of a minus log of b is equal to log of a over b. So we have an x minus 1 on top and an x plus 2 on bottom, plus 1/3 1 over x plus 2. And remember, we didn't have any limits, so it's an indefinite integral. So I'd see, and I guess I should put that up there. And just notation. That's how you do partial fractions.